take a moment to do this. I'll go over these answers, so pause until you are ready. So conversion formulas for polar to rectangular. So if we're going from polar to rectangular, that means I have r and theta, and I want to get x and y. So x is equal to r cosine theta, and y is equal to r sine theta. If I'm going from rectangular to polar, that means I have x and y, and I'm trying to get r and theta. So you may remember that r equals plus or minus the square root of x squared plus y squared, and theta is equal to tan inverse of y over x. So those are the four. In terms of what is the shape of the graph of this function. Oh, I forgot. I erased that accidentally. I'm going to pause this for just a second and I'll write the equation. Okay, so yeah, I accidentally erased the problem that was here. X squared plus y squared minus 6x plus 2y plus 1 equals 0. Take a moment to do that problem if you haven't. Well, you obviously haven't already, so go ahead and take a moment to do that one. It is a circle. Since it's x squared plus y squared, we just need to figure out where the center is and what the radius is. So I'm going to group the x terms together and the y terms together. X squared minus 6x and plus y squared plus 2y. And I'll move that 1 to the other side. To complete the square for the x's, I'm going to add 9 to both sides. And for the y's, I'm going to add 1 to both sides there. I can now rewrite this as x minus 3 squared plus y plus 1 quantity squared equals 9. I now know that the center is 3, negative 1, and the radius is 3. Okay, moving on. These are some of the essential skills that you will need for today's lesson. So let's get right into it. The packet. Last time we talked about converting polar coordinates to rectangular coordinates and vice versa. This time we're talking about rectangular equations to polar equations. So the first one, x squared plus y squared equals 16. We could already graph this. We know what this is. You better know what it is. A circle, radius 4. So we'll go in that direction, each direction. There we go. There's a circle. But that's not the question isn't asking us to graph it. The question is asking us to change it to into polar equations. So you may remember one of our equations said r equals plus or minus square root of x squared plus y squared. But remember that just comes from r squared equals x squared plus y squared. So the x squared plus y squared, I could just replace that with r squared equals 16. And when you're in a polar equation, normally we solve for r. So I'm going to solve this. We have r equals plus or minus 4. So those are two different equations. But I hope you can see, and I hope it makes sense, that this is the equation of a circle that is radius 4. Think about polar coordinates. Think about that polar axis revolving around the pole, and it's just drawing a line where, or not a line, but drawing a path where r is equal to 4. It makes a perfect circle. In fact, it's a lot more elegant, I think, than the kind of clunky x squared plus y squared equals 16. R equals negative 4. Think about how that would work as you move your axis around the pole. You're tracing out the r equals negative 4 values. It traces the same circle. This one of the big questions is what's under the radical? And it's only the 3, which makes that a line with a slope of root 3. So I could graph that. Means I go up root 3, which is about 1.732, and over 1, or I can mark on there, square root of 3 over 1. So it looks something like that. That's our line. Okay, but again, the question is asking us to change this to polar equations. I'm going to be a little bit sneaky here and divide both sides by x. y over x equals root 3. Y over x, and again, if we go back to our equations here, from this, right before this, it was actually tangent of theta equals y over x. Hope you remember that. Everything comes from this relationship here between r theta, x, and y. So tangent of theta equals y over x. And because of that, I could take that and substitute it back where I'm working. So this is just tangent of theta equals root 3. Now this is actually a problem we could solve. We could solve for theta here. You think about our unit circle. Where is for which values of theta is tangent equal to root 3? Take a minute to think about it. And the answers are here and here. You could verify that if you like with the coordinates. 1/2 comma root 3 over 2. Negative 1/2 comma root 3 over negative root 3 over 2. So I'm just going to choose one of those. X equals, theta equals pi over 3. Now compare that to the graph that we originally started with. Do you see the connection? It's just a line in the direction of pi over 3. So in this case, r is completely gone, which means our equation, our polar graph just fills in that direction, pi over 3, because no matter what r is, the points will satisfy that condition, theta equals pi over 3, both for positive values or negative values. We could also say theta equals 4 pi over 3, and that would yield the same line. Either answer is correct. Okay, next. X equals -2. I'm going to graph this once again. X equals -2 is what kind of a line? Don't say straight. It is vertical. It's passing through the x-axis at -2. But again, that's not the point of this exercise. We're converting from rectangular to polar. And we remember that x equals r cosine theta. So I'm just going to replace that with r cosine theta equals -2. As you may have heard when I talked about the first one, we typically solve for r when we do this. So r equals -2 over cosine theta. And although this is a polar equation, we're going to clean this up a little bit by recognizing that this is the same thing as saying -2 times, you know what I'm about to say, 1 over cosine theta. You see where I'm going here, don't you? So r equals -2 times secant theta. That's what I'd be looking for. So that r equals -2 secant theta is an equation of a vertical line that passes through the point -2. Now that is definitely not as intuitive as like the first one. In my opinion, is super intuitive. R is equal to 4, circle radius 4. Perhaps it makes sense that if theta equals pi over 3, we're just going in pi over 3. That direction is filling in every value of r because it's not based on r. This one, I'm not going to try to give it to you in any sort of intuitive way. I'm just going to ask you to trust me that that is true. Okay, change these into rectangular equations. I'm going to change this because we just did secant. So instead of secant theta, let's do cosecant of theta. Okay, so we know that r is equal to, oh, did you pause it? Did you already do it? So secant theta is the same thing as 1 over sine theta. I'm going to multiply both sides by sine theta. We have r sine theta equals to, and now you may recognize that r sine theta from our conversion equations. R sine theta is equal to, what is it? Oh, that's y. Y is equal to 2. And now I could actually graph this if I wanted to. It doesn't say to, but I'm just trying to be complete here. This one. This one was nice once we got here because we had an r sine theta. If we have r cosine theta or r sine theta, we are set. Here we don't have an r on that side. If you try to divide both sides, please don't, you'll get this, which is nothing. And you could try to change that, and it's true that this is equal to this, but again, we don't have an expression for r secant theta, so that's not helpful. So I'm going to go back and say, I'd really like to have r cosine theta. I'd really like to have that. So what do? I make my own destiny. I make it happen. All I do is I have to multiply both sides by r. You have r squared equals 2r cosine theta. On the right side, that r cosine theta makes us happy with just an x. How about r squared? Well, like we said before, that is x squared plus y squared. Just we went the other way last time. So what shape is this? You should recognize it's a circle. I'm going to complete this. X plus y squared. I left a space there, of course, to complete the square. Plus 1. X minus 1 squared plus y equals 1. So we know that the center is at 1, 0, and it has a radius of 1. So it looks something like that. Okay, we're going to do a few more problems just for some practice. In this case, it's saying to graph them. I'm going to tell you not to do r equals theta. Let's do the rest. And take some time to turn this off and see if you could do what we just did and apply them to graph all of these. I'm going to go ahead and do them all. R is equal to 3, circle radius 3. There's a 3 everywhere. Now, yes, those are all positive 3s. And for polar coordinates, the x and y axes don't really exist. There's just a single axis, but we do put them there for reference. So it may make sense to just put a 3 all the way around, right? R is equal to 3 wherever we go. That's highly unstandard, of course, and you would never need to do that on a test or quiz. You just need to mark that one of them is 3, and then I know the rest, but that's what's going on there. R is equal to 3. If I draw in the radii, you can see R equals 3. Of course, that isn't part of the graph. Those little lines, that's just showing in that direction. I've gone and drawn a point at the end of each one of those directions. R sine theta equals 2. You know this is y equals 2. Done. R equals -3 secant theta. Think about that as 1 over cosine theta. If you like, you just multiply both sides by cosine theta since they're reciprocal functions. They cancel, leaving us with r cosine theta equals -3. So x equals -3. Graphing it, that one is a vertical line crosses the x-axis. And lastly, here we multiply both sides by r. So now I have x squared plus y squared equals 4y. That's an equal sign there. And I can continue this. Exactly the same process. We're adding 4. We now have x squared plus y minus 2 quantity squared equals 4. So we have a circle whose center is at 0, 2 with radius 2. So it's going to go up here, go here, and here. Excuse my warbly stylus. It's just a technological issue I'm having. My hand isn't really that shaky. Okay, so that is the end of the lesson, but I'm going to continue with a video of me presenting an important connection for next time. So make sure to continue watching so you could get some insight into the problem I just did.
So what I'm going to do today is I'm going to give you a preview of what's to come next time. So what I'd like you to do is don't worry about taking notes. In fact, leave your pencils on the desk and just watch, just listen and enjoy. I'm going to go over the very last problem that we did. Specifically, r equals 4 sine theta. I think, is that what it said? Yeah. Okay, so I'm going to talk about how to graph this, how to think about this as a polar equation. And in order to do this, then I want you to make sure you're following closely along. I'm going to use what's called the helper graph, meaning I'm going to graph this in a more familiar sense. I'm going to graph our normal sine wave. What's that? Exactly. I am going to graph the sine graph. So instead of calling this x and y, I'm going to call this the theta axis in our axis, just temporarily. And I'm gonna graph this in a rectangular fashion and then move it to polar and try to show you the connection between the two. Do you know what a sine graph looks like? What does it look like? Its origin and does something like this, right? So you know that the period is 2 pi, and just put this into 4 pieces because there are. We're splitting 4 pieces. 4 quadrants, thank you. And we know the amplitude is 4. Right, we're back to rectangle. We're back here. So I have my 5 points. We don't need to graph this. 3, 4, 5. This is my graph in rectangular. Okay, what I'm gonna do is I'm gonna change this and put all this information to the polar graph. And I'm gonna do this quadrant by quadrant. Now, in the first quadrant, from 0 to pi over 2, according to my helper graph, what's happening to the radii? It's increasing from 0 to 4. You see that in my first quadrant from 0, when theta is going from 0 to pi, not pi over 2, r is increasing from 0 to 4. Now, when I just had a circle, r equals 4, what happens is it would start at 4 and just stay there, wouldn't it? Just navigate that r in the first quadrant. But this one, starting at 0, increasing to 4, what's going to happen? Get out of the way. Is you start here at 0 and it's going to open up to 4. And do that one more time. Does that make sense? What I'm doing with my hand, I'm turning that 1 quarter. Yeah. Right. I'm just saying that first quadrant, 0 to 5. And instead of staying at 4, keeping it at 4 and start at 0, open up to 4 like that. Increase it to that. And we're at 4. And the next quadrant, from pi over 2 to pi, the r's are going from 4 to 0. It doesn't stay at 4. If I stay at 4, it will look like this. Starts at 4 and closes to 0. Does this look familiar so far? Yeah. It looks like our graph, which was a circle whose center was at 0, 2, with a radius of 2. It's looking like that, isn't it? But what happens when you go past the pi? The radii become negative. So let's think about what's happening from pi to 3 pi over 2. From pi to 3 pi over 2. So I'm right here. Pi to 3 pi over 2. What's happening to the radii there? Am I making another circle? So it's the other way. Right, so what's happening here is that these radii are 0, 2. That's not 4. No, but it would go back. -4, isn't it? Yeah. Right? Doesn't it say on my helper graph that when theta equals 3 pi over 2, r is equal to -4? Hasn't that just happened right now? So what I've gone from, so here is 0, up to -4, and after -4, what happens? Goes it back to 0, and then what happens after 2 pi? It repeats. So what I want you to do, oh, yeah, Patrick?
Why is that also negative?
Because it depends on our orientation, right? R comma theta. If we're pointed this direction, that is 4.
Oh,
If we're pointed this
yeah.
direction, this is positive 4.
because that's the 2 quadrant that it's going. Not because you're pointing down because of the quadrant.
Just because it's directional. So 0, pi over 2, pi. This is 3 pi over 2 down this way, which means this way is positive now.
So that's a negative.
Yeah, but this is negative. So that's not only 4, but negative.
4.
Yeah, so I want to take another look at this circle. Here's my axis, my polar axis. I want you to see the sine wave. You see it going from 0 to 4 to 0 to -4 to 0. The same thing here. It's happening here just in the polar graph. So that's a summary of what's going to happen next time. You won't need to do any of that for your homework tonight. But if you liked what we just did, you may want to do the connection with the secant graph that we did when we graphed R equals 2 secant theta at the beginning. You may want to look at that with a helper graph. But that's all I got for you. If you have any questions, you're welcome to ask. I do have 2 things for you. I have your quizzes, I have your grade report, and you have time to work on your homework.
Yeah.
Sure.